Hello, my name is Luke Herblin. I'm a first year in computer sciences. My pronouns are he, him, and I'm applying to be ULA for CS24 and CS40 with Professor Mirza and Majedi respectively. And now I'm excited to be ULA because I just really find a passion for kind of helping my peers along through topics. And I've always had the thought that teaching is the best way of learning something, because how better are you going to understand something if you can actually teach it to someone? And I also had a lot of help from the ULAs when going through CS24 during office hours and stuff, which helps me really succeed in the course. Now, the topic I'm choosing is Rule of 3, which is something I learned in CS24, and I've also learned a couple of things about some of these functions in CS32. Now, the Rule of 3 is when you have an object or a class that you are making that uses dynamic memory or memory that is on the heap, you need to implement all three of these. Now, the destructor makes sense because say you're implementing like a linked list or a binary tree where all you have that the object knows about or that's on the stack is the head. And then from the head, or a pointer to the head, then everything that is on the heap, you don't have direct access to, but you need to increment onto using pointers to get to. So now with the destructor, you have to implement basically going to the head and then going along as you delete along the way with the linked list. Now the copy constructor, you have to implement this, and when implementing this, people oftentimes write it just like this, where it's just the function name and then the object as the input. But something is incorrect about this. What's incorrect about this is that you actually need to pass it by reference. And if you don't pass it by reference, it's going to create an infinite loop and cause a segmentation fault. Now, the reason it does this is because in the compiler, when you're calling a function and you input it with an object, what's going to happen if it's not passed by reference is it's going to make a copy of that object within the function. Now you can kind of see the problem. In our copy constructor, we're making another copy of our object. And then in that copy constructor, it's going to make another copy and another copy, and it's going to become an infinite loop. That will cause segmentation fault, and we don't like those because we want our code to work. Now, with the overloaded assignment operator, typically a good thing to keep in mind is usually with our functions, we do want to pass by reference, especially in cases with like this, where we have to go through the entire object and copy all of it, because we could just pass it as a normal object, but if we pass it by reference, then we won't be copying all our data from our giant object, because we don't know how big our object is. It could be tons of data, and if you copy it in a function, that's just not very efficient, whereas you could just pass it by reference. Now, this is great and all, while I do and returning just the object itself, it seems good. Our code works when you do like A equals B, and then like B equals C, but here's another issue. We can't, however, do C equals B equals A. That seems like it would work, but it doesn't. And the reason for that is because when we get to the C equals B, we're passing it by reference, but here it's getting an object. And so the way we fix that is we just return a reference instead of returning an actual object. We return a reference of our new object, and then this way we can do this for as long as we want. We could do D equals C equals B equals A, and it would just all work. Now the reason why is because in C++, of course, you can't, if you were to pass an object to this overloaded assignment operator, it wouldn't know to call this overloaded assignment operator because it's expecting a reference. And by returning a reference, we could just keep doing that over and over, which is useful because it makes logical sense to be able to do this. Say you want to assign two objects that A to be this, like say we wanted to assign basically C and B are equal A. This is how you do it. And if we weren't able to do that, that would be a bit of a problem. Now, thank you. That was my little brief intro to Rule of 3, and I hope to be working with you guys more in the future. Bye-bye.